Good morning, children. Today we'll take the topic of combination of resistors. Combination means when we are going to take more than one resistance at the same time in a given circuit. So combination of resistors. Now the first question comes that how we can combine the resistors. So there are two main ways of combining the given resistor or having combination of resistors. One is series and another is parallel. That is, we can combine two or more resistances in series or in parallel. So today first we'll talk about the series combination of resistor. Now as the name suggests, you can just think about a series, that is one end of one resistor is connected to the other end of the second resistor, and then they are forming a chain like structure like this. Say that this is resistance 1, say R1, then this will be resistance R2, and then say R3. We are taking three resistance together. So one end of the resistor is connected to the first end of the second one, and then second of the second resistor is connected to the first end of the resistor third. So they are forming a chain like structure. So if these are combined, what resistance I will get in result? Or I can say in other words that if I don't want to have the three resistors in a given circuit, I want only one in place of these three, then what will be the value of that resistor? So this is what we are going to do. Let these combination of resistor be connected to a source of potential difference, say V. Now as soon as a source of potential difference will be connected across this combination, a current, say I, will start flowing in the circuit. And as you can see, there is only one pathway where current can move. So current is going to remain same in all the three resistors. So this is the first condition of which you shall remember, that in series combination current remains same through each resistor. So same current is going to flow through each resistor. Now when current is same through each resistor, then that means potential difference across the ends of a given resistor must be different according to Ohm's law. What is Ohm's law saying? V is equals to IR. I is same, R is different. So potential difference across each resistor will be different. Let us consider the potential difference V1 across the resistance R1, V2 across the resistance R2, and V3 across the resistance R3. This can also be measured using a voltmeter in parallel, like this. We can connect a voltmeter across each of these three resistors. So I'll get the value in that voltmeter. Clear? Now whatever potential difference we have applied, current is flowing because of that potential difference only. So this V must be equal to V1 plus V2 plus V3. Now we'll use Ohm's law. V is equals to IR. So V1 will be equals to I into R1 plus I into R2 plus I into R3. Now what we have to do is, we are going to replace these three resistors by a single resistor. Let us say a single resistor is connected across these potential difference, and current must remain same. It's the same I. So let this resistor, certainly this resistor neither will be R1 nor R2 nor R3. So let it take it for this RS. That is, this is indicating resistance in series combination. Now when I take resistor in series combination as RS, whole of the potential will now drop across RS itself, because there is only one resistance. So whole V is across RS only. And if I use Ohm's law, what will be V now in this case? I into RS. So V is now I into RS. So what I'll get as RS is equals to R1 plus R2 plus R3. So in series combination, the resultant resistance will be simple, the algebraic addition of all the resistance which are connected in series. And you can see from here, this value of resistance RS will be more than each of these individual resistances. So in series combination, what we have understood is that certainly this is the formula which we have derived, that series resistance will be simply the additions of R1, R2 and R3. The other thing which you have to remember always is that current remains same in series combination, whereas potential across each resistor will be different. And third thing, the total potential difference which we have applied will be, a part of that will get dropped across each of the resistor depending upon the value of resistor. You can see as I remains same, more potential will drop with more resistance. More resistance, more potential drop. Less resistance, less potential drop. Clear? Now this is about series combination of resistance. I can take one example. We can take it from NCERT book, question number 9. It says that there are 5 resistances connected in series. Question number 9. And this is connected across a potential difference of 9 volt. The value of the resistors are 0.2 ohm, 0.3 ohm, 0.4 ohm, 0.5 ohm and then 12 ohms. These are the 5 resistances which are connected in series. And they are asking how much current will flow through a 12 ohm resistor. The question is how much current is going to flow through the 12 ohm resistor. So the very first thing which you have to keep in mind is, what type of connection is this? Series. So current will remain same through each resistor. Simple. Now you know what will the equivalent resistance, what will be RS? RS will be 0.2 plus 0.3 plus 0.4 plus 0.5 plus 12. This is going to give me 5, 4, 9 and 3, 12. 12 and 2. 5 and 4, 9 and 3, 12 plus 2, 14, 1.4 plus 12. This is going to give me 13.4 ohm. And what will be my answer? V is equals to IRS. So what will be I equals to? 9 upon 13.4. This you'll get the answer as. You can simply divide yourself. And this current series is going to remain same through all these resistors. So current through 12 ohm resistance will also be this value. Clear? And suppose they ask you the potential drop across each resistor, then what will happen? Current is same. You already know the value of current. I multiplied by this will be the potential drop across this. I multiplied by this will give you the potential drop across this. Alright? So in this way you can solve this question. So you'll read this and then we'll go in for combination of parallel in the next term. Thank you.